flux, magnetic flux. So like electric flux, it's literally the same idea. We have our Greek symbol phi, so B will be the double integral of B dot dA in the most general form. So you've got some surface, you've got some magnetic field flowing perpendicularly through that surface, or that's what we're measuring. BA, this vector here, is a vector that points perpendicularly or normal to the surface. And I want to measure how much of that B flows in the direction of that parallel or that perpendicular vector. How much of B flows straight through my surface? Well, that's a dot product. The dot product finds the parallel component between B and that normal vector. Okay, so that's in the most general term. If you guys had already taken Calc 3, we would actually do problems like this. This is a Calc 3 problem. Since you haven't been forced to take Calc 3, I think you should be. Then in the simple case, we get magnitude of B times area times cosine of the angle between them. So this is for constant B. Then I have some area. I've got B flowing through that area. Then the amount of flux that flows through that area is the magnitude of B times your area. And now I promise you, every problem you see about magnetic flux, they're going to give you the wrong angle on purpose, just to see if you're paying attention to this moment. This angle here is the angle between B and the normal vector. So if I had, here's a common problem they like to put in homework. I've got my area is flat here. I've got B coming down at some angle like this. So maybe this is the ground and I've got the Earth's magnetic field and we're assuming it's constant and it's coming down at some angle, flowing through the surface of the Earth. I promise you, they're always going to give you this angle here, the angle between the flat surface and your magnetic field. That's not the angle you want. You want this angle. This is phi. The angle between B and straight perpendicularly through the surface. So I don't know, let's make up some numbers here. Let's say my B is, let's say it's a huge magnetic field, 5 Tesla, and say this is a 20-degree angle here. And let's say our rectangle is, I don't know, 3 meters by 2 meters. Then the amount of flux that passes through there would be magnitude of B, 5, times my area, which is what, 6 square meters, times cosine of not this angle, which would be 70 degrees. And then whatever that is, I don't feel like typing that in. That's going to be measured in Tesla per square meter.